Hello, welcome to another lecture on PyTorch. So in this lecture, what we'll do is we have already built a simple KNN model where we define a model using NN sequential. We did this all the procedure like forward pass, loss calculation, backward pass, parameter updates in the last class, and we haven't seen model evaluation, so we'll do that and we'll improve the model using nn.module and torch.optim. So this nn dot module will help us in writing a class. So as of now, we have written the code where I'm calling this model as nn dot sequential, right? It's not yet a class, so I have to make it as a class, and update will do so that you can reproduce the code again and again, and it will be easier for you. So for that purpose, we have to do that, and we we need to optimize also, right? So we need to use some kind of optimizers. For example, SGD. There is another Adam RMS prop. Such optimizers we have to use, right? So this thing we have to change. And another thing we have to do is we as of now we are training this in the CPU. So we have to learn how to train this into a GPU. So for that you need a GPU. So if you are using Colab gives GPU. So you just have to go to change runtime and you have to select T4 GPU. Right? So this is a GPU the given by the Google Colab, and you can use that. Now let's see how first we can do computation in GPU. Okay, so what we have to make changes in the code. So I have already imported my data. I have imported this NL library also. Now let's do for the few imports in this. Let's say I'll do from torch import optim. So one is this. This will help you in writing the optimizers. And another thing I'll import is from torch utils. I'll import data set and data load. So this data loader will help us in doing the batching of the data or shuffling of the data, something like that. This loader will help you in that. Okay. Now, data set is another where you do some kind of preparation. If you want to do in the data set, you can write in this class. Okay. So I have imported that. Now let's see how I can do or how I can write this into a. So as of now, my data, as you can see, uh, I have train test done. Now you can see Xtrain is just in the CPU. Like there is no mention of device in this. So what we have to do is we have to say dot dot CUDA dot is available. If I write this is a true. Right? So in this case, I have a CUDA device available, which is my GPU. So if that is true, then I can write a condition. So let's say CUDA if this condition is true, else say C. So if I write this, then I get to the right. Now what I can do, I can store this into a variable. So this variable name is very specific. What you have to do, you can use anything, but you have to first say torch dot device, and inside this you can store this uh, function, right? So whatever we have written, you can store this inside this. So the device will say that, okay, this device I have available. Now I can store in some variable name. Anything is fine, but let's call this as a device. It's just easy for this. So this device is being stored here. Now what we can do, uh, we haven't mentioned when we are doing when we are converting this value into tensor that where we are storing it, right? So by default it stores the CPU, but we have to move it to GPU. So how will I do that? I'll say device equal to device. So the other device is coming from here. This is a variable name. Okay, so parameter. It's a parameter, but this is a value of that. Now I'll use same thing for all four of them. So, like, okay. Now, if I show you that string, how does it look like? You can see it is in my CUDA 0 device. Right? So I have moved my data to the GPU. So this will helpful when I move my model also to GPU, and then I'll do the forward propagation. So we have already written the code. So let's do that. So one thing before I do that, so I have mentioned my loss function inside this loop. I'm initializing here, which is not the correct way. You should initialize it outside of the loop. So that you should do here. Now, um, now yeah. So I have done this. Now my model is there. Now I have to what I have to do is I have to say model dot to and I have to say device. So this device is again the one variable I have stored up, right? So that way I have to just run this. So you can see this is happening in CUDA. My data, which is in this X-train, right? So X-train was and CUDA, and my Y train was also going to be CUDA, and rest of this, all the computation, loss calculation, everything will happen in the GPU, right? So this is how I'm doing in a GPU computation. Now, as of now, it doesn't make much difference here. You might see not very negligible change in terms of computation time. But if you run a CNN architecture or something like that, which will be in week 4 or week 5, then you will see these changes. Okay, that it is taking a lot more time if I do with CPU. So that is there one upgradation onto this. Now let's convert this to a class. So how will I write this class? So what I'll do, I'll just copy this whole thing. Um, I already imported my NN at up, but let it be there. No issues. Now what I need to do is I need to put all of this thing inside a class. So I'll say I'll define sorry I'll say class um, my let's say my model, and I'll say I'll inherit something which is called nn dot module. So this nn dot module will be the class which will give you what is orbit means, what is um, uh, the rest of the function also you can use. For example, upgrade parameters. If you write model dot parameters, it will be given by nn dot module, right? So something like that. Now you have to write a constructor class. So for that you have to write there double underscore. You have to say init again double underscore bracket, and this is my constructor class. Okay. So this constructor class is a consistent like you have to always write like this. Now, some inputs I have to give in this. One is self itself, I mean self, and another is what kind of input I want to give. So for example, I'm giving in features 10 here, right? So instead of that, I can create a in feature and say that I'll whatever this is, I'm going to give you here. Right? So for example, like this. Now, another change you can do with out feature also that my out feature is something, and whatever value I choose, I'll give it there. Okay. So I'm choosing the same variable name. It's not necessary that you should choose this only. You can choose anything. Like for example, just this also fine, right? But you should know what does this mean. So you have to remember this then, right? So I this is also fine. You have to remember that what is this, right? So I'm just letting it whatever it is here, so that I don't need to remember any right? Now, I guess that should be clear. Now, I have to inherit from this. So I'll write super and I'll say this, right? So this will inherit my nn dot module in this class. Now, as of now, I'm here. Now I have to say something like let's say self dot my network or anything, my model self dot network. And whatever I have written here, the sequential part, I'll give it there like this. Now all these things are in my so it is there. My network is there. Now I need to say what is my another function I have to or another method I have to write is what is pop, right? So how will I write? I will write actually this is It's going to be def. Then I'll write forward, and I have to give self in this and whatever my input is, right? So I'm calling input as x as of now, and I have to write what it will do. So it will return me self. So I'll return self dot network, and I can give x to this. So it's your choice, right? You want to write forward after this or not? Both the things are same. So PyTorch recommends that you don't use forward in this. I just save some time, and I guess PyTorch recommends that, so you can use that, right? So no need to write forward here, but it's like inherently it's there, right? Now this is my class. So let's say if I want to create an object of this, let's say or let's say model one is my model, and I have to give in features, right? So how many in features I'm expecting? 10. How many out features? 1. So if I do that, so it is being initialized, right? You can see it is being initialized. Now, what you can do, you can from torch summary import the summary, and you can do something like this, right? So if I run this, um, to be on same device. Okay, so the issue is that my I guess my device is not on CUDA, but other things is in CUDA, something like that. So what I need to do is I have to say model dot to device, and then it shows, right. So it shows that this is how my data looks like, right? So model one, and this my end. Okay. Now um, since I've already moved it to the device, I don't need to redo it again, but still when I write the code, I'll do it. So let's just copy this code and paste it here, and we'll update that. So what I am doing here, I don't need to write all of this. I just need to write uh, this two things here. Okay, that my model is this, and model one I'm sending it to device. Okay, so that is required. Now, what kind of loss function? I'm using the same loss function, so nothing to be changed here. Now I have to choose what kind of optimizers. So for easiest purpose, let's use the SGD optimizer because most of the people know what is SGD optimizer. So what we'll create a optimizer is equal to torch.optim SGD and some learning rate you define. So in this, you have to give two things. One is model, one is parameter. So whatever the parameters of this, right? So model one dot parameters. Now you are going to get a generator object, right? So I have explained what is this. If you want to read this, you can say something like print star. Okay, something like this you can do. It will show you. But is this a generator? You don't need to read that. You just have to give that generator here. So just remember that you have to give that generator functionality. You won't give any other type of function in that. Okay. So okay. Now I'm giving a learning rate also for three epochs that run for that. Now I don't need this learning rate here. I have given it there, so I don't need to do that. Now epochs, this is fine. Y hat, I'm still doing model dot forward. It should be model one. See, now I can actually remove this forward also. I can actually remove forward in the last code also. Thing changes there also. It's up to you. So PyTorch recommends this way, so that's why I'm writing it. Now Y hat squeeze, and then Y train, that is fine. Loss, I'm printing that. Back but pass that needs to be done. Now how I'm going to upgrade my test plane, and how I'm going to make them create and see. So so earlier what we used to do, we were making the gradient zero after doing that. Right? So as a backup or as a precaution, what we should do, we should before even doing the backward pass, we should make them zero. So that we ensure that our gradients are always zero when I start the loop, right? So how I'm going to do that? I'm going to write before the backward pass that uh, optimizer dot zero gradient. So I have to write this much, and it will make the gradient of which are stored in optimizer as zero. Right. So my gradients are now in the optimizer. That's why I have to write that. Okay. Now I'll do the backward pass. That will I'll definitely do. Now I have to update the thing. Right. So how I'm going to update? I for that is there's a code called optimizer dot step. Just that. So you just have to mention step. That's all. So this will do the part where you are updates update the weights. Fine. So I've done this. Let's see what. Now I've run this, and we are going to get this loss function. Right now, you can actually run this for more epochs. It's up to you. Okay, so it will do very fast calculation in this. Now, one more thing you should do is there's a prime printing loss here, which you can see it is giving MSE loss backward something like that. But instead of doing that, you should actually print whatever the values are there in that something like this. So it's a better way to do that. But this might be an issue in a computation graph. Now another thing could be okay. So we have done that optimization. We have seen how to make gradient zero, how to update the weights. So I guess most of the task is done here. Now let's see what kind of updates we can do. We have almost done that. Optim we have done. So let's see how we can do batching. And yeah, so let's see how we can use the data loader and we can do the batching. Okay, so that's that one thing is left as of now. So as of now, what we are doing. We are using the whole data. Though even though I'm using SGD, it will not make much difference. So SGD by default works as a GD. Okay, like the normal or batch gradient descent, you can say the whole batch is being computed in this way. So you have to actually mention this while passing to the thing, while passing the data that you are going to pass one point at a time or a batch at a time or what are you going to do, right? So let's try to do mini batch gradient descent. That will be easier to understand, and then we can see what we can do about it, right? Uh, yeah, so okay, before that, I think I forgot that how to do the evaluation part. Now, see, I have done this training part. Now, whenever I do the training, what I need to do, I need to set my model to training phase, right? So, how will I do that? Model one dot training phase, right? That means this model is my in training phase, right? Training phase. Now, if I want to set my model to evaluation form, model to evaluation phase, what I'll write model one dot eval. So if I write this, that means it is in a evaluation phase. Now, as of now, you will not see any difference in this. It looks almost similar to you. So what you can do in this model definition, right? So when we define the model, you can add something like as a let's say batch normalization. Let's say nn dot batch norm 1D, and you have to mention this 8 is coming from here. Right? So whatever this out features are, you have to mention that. And sigmoid you are applying on that. So this is my first layer. You can use something called dropouts layer. So this dropout layer says so you can say and drop dropout. Now here you have to mention what kind of probability you want to use, right? So let's say p equal to n point 3 or point 0.5 or anything. So that is fine. Now so similar thing you can do here also. I'm not doing it. It's up to you. You can do it. Now my model is changing a little bit. So, okay. So you can see now I have dropout patch now, which has some parameters, and dropout also, which doesn't have any parameter. Right? So some things that is changing here. Now when I do the training, that time this behave differently, batch normalization and dropouts. But while testing, they behave differently, right? So while testing, we don't drop any neurons. We consider all of them, but it has some. It was backpropagated with some probability, right? So that's why it would have a different kind of weight updates in that case. So if you don't know what this batch norm and dropouts are, I would suggest you can go to the deep learning playlist and watch this part. Okay. Now, okay, so now my model has changed a bit. So I'm calling my model here. Everything is there. Let's train this. So for optimizer, that's why I have to do the evaluation. So when I do the evaluation, my batch norm and dropouts will freeze. Okay, so this will freeze. It will not update or it will not change, or my parameters are there in the batch norm. It will not change or something like that. Right? It will be some exponential moving average or something like that. So it will use that. Now, so now I have to test the model, right? So when I test the model, we need to do gradient update, right? So I'm doing this updates and this. Do I need to do that? No. So for that, I'll set torch dot. I'll set torch uh, with right, with torch dot no grad. So in this, I don't need any gradient computation or anything. That's what I'm mentioning here. And I'll say again my code for my this part y hat and all will not change. So I don't need to use epoch here. So I'll just say forward pass this much compute loss print loss dot idle. Okay. Yeah, so forward pass I'll do that. No, but now I'm going to give instead of train I'm going to give test, and here y hat this one only. So nothing changes there. White test, and I think we can do that. So this is what I'm getting a loss on test set. So this is how you can evaluate the model. So this is how you can train the model. You can evaluate model. Just remember that you have to set it to evaluation mode, and when you're training, you set it to training phase. So this is just a reminder that this is a training going to happen there. Okay. Even though without this, so if you run, that is fine. It will not take that. Okay, now let's see what we are going to do. We are going to do is yeah. So we are going to use data loader in this case, right? So how to use a data loader in this, we will see that. So what I do is I have to import this data loader, okay, and I have to give my x and y both together, x tensor and y tensor both of them together. But it will be very hectic to do that. So one thing you can do, you can import from torch. What I'm doing, I can from torch dot utils dot data, I can import another thing called tensor data set. So this data loader is already imported, but I need tensor data set. So what it do is you can give both x and y to this, and it will send you both of them, right? So x string, y train, and you give you'll get this data set object out of this, right? So this data set object will be helpful in data loader. So if it is not data set object, then this train loader will not work most likely. Okay, so that's what we will do. We'll give that here, okay, as input, and then we'll choose some batch size. Let's say 33 or something, and we have to do shuffle equal to true in this case. So this is for test training the data set. So I'll call this as a train loader. Okay. And similarly, I have to do the whole thing for test loader also, right? So test loader will be something like this. Okay, so well, okay, so here I do need to actually give a shuffling to. The reason is I want to evaluate consistency, right? So I want my consistency and my evaluation. When I do the evaluation, that is the label changing for this particular data set or not, right? So that's what I want. I want consistency here. But while training, I need to train my model in such a way that it can handle any way my data is given, right? So if I give in a one way, it might learn some patterns in that way. So if I change my data, it's a good way. So I need to maintain a consistency here, right? So that's why. So now what you can do, you can, let's say, for uh, feature comma label in train loader, you can print. Okay, so you can see that I'm getting the features here like this. These are my features and labels it. So I think plural would be better. Right? Okay. So this is how it is. So I'll use this batching thing to train the data set. Yes. So to train the model, right? So I need to do for the mini batch gradient descent, right? So how will I do that is I will take this whole thing here and let's take both of them. So I'm taking this one and evaluation also and pasting it after this. Okay. So here I'll just mention what I'm doing, trying to do. I'm trying to do a mini batch gradient list. Okay. So this is my model again. I'm just initializing it. It's for you, but that will work which we initialize. So I'm using same loss. We're going to use same optimizer SGD. For three epoch I'll do. Model one dot training phase, I'm starting that epochs. Forward pass, now something changed here that I can't give the whole data set now. I want to give in batches, right? So for that, I'll use this part. Okay. So I'm breaking it. That's why I'm getting one. But if I don't break, I'll get the whole thing. Okay. So I'll not take break there. I'll take this much. I don't need to print this, but I what I need for them is I need them for uh, model one dot train and sorry model one and feature, right? So that just kind of like forward is the one I need to use, but that's okay. I can do without that. Now training is done. Now I have to compute the loss also inside this, right? So I have to compute my loss for this also. So what I'll do, I'll say um, something like this. This is good enough. Now loss I'm computing. Now y head instead of y head, I'll say labels. Do I need to squeeze them? I don't think so. I need to squeeze them now because I'm getting them in a list already, right? So that is fine. I can actually skip this. Uh, maybe so this is not labels. It should be labels. Should be like these are my labels. This is my y pred only, which I did earlier. So I whatever my y hat is, I let it be y hat is equal to this, right? So, and y hat I was squeezing out also, let it be there. Now, one thing is that when I get my data, I have to generally move them to the GPU. So, what I'll do, feature is equal to features dot to device, labels dot to device. So, if I do that, I'm moving my data set to the GPU while training. So it's like we are taking one batch, putting them into GPU, done the training, then kind of erase it, and then another data goes ahead. So your GPU will not get filled with this, right? So if you do in batching, we can train a small batch which we can send to GPU, and then training is done, we can remove that, right? So something like that we can do here. Now for each batch, I need to optimize my this thing, right? So I have to move that also inside this. So remove that. And of course, I have to do this part also and this part also. So all of this thing will go inside another folder. That is the only difference you have to make there. And um, And what you can do is, you can before you start a epoch, you can say you can store something like loss, let's say per epoch. So we need to actually see how much loss I'm getting per epoch, right? Per batch doesn't mean much important here. So that we can do. Now we can store this loss per epoch in the loss item in that, right? And after once this epoch is done, we can print them. So for that, I'll write print, and that would be loss per epoch, right? So that I can print that. Now let's run this. So I don't need to print this. I just need to print this. And for three epochs, I'm getting the error. Right? So this different error I'm getting for this. So it is reducing from 15 to 64 and 54. Right? So it's a good model training happening there with this learning rate and all. It's a good learning rate also. If you are getting another result, you might need to reduce the learning rate. Right? So it might overshoot sometimes. So make sure that your learning rate is appropriate. Um, so that is done here. Now let's see what we have to do in evaluation part also. So we have no bread and forward pass we are doing. Now I'll just take this part up till the loss where I'm doing the loss calculation and uh, something like this. And I'll remove all of this and that's it. So why I'm doing loss per epoch again? The reason is same, right? So maybe let's say your data is very huge and your GPU might get filled. So yeah, remember that we are going to do this in GPU, right? So I should do that here also, right? So instead of train loader, just one thing I need to change, but that is test loader. And rest all remains same, right? So labels is fine. Epoch, loss per epoch, loss item, and then after once the loop is over, I can print it. Okay. So something else. So this is my test error and this is my training error. So what I'm doing a SGD mini batch SGD in this case. Okay. And yeah, so that's all there for this lecture. Thank you all.